All right, Panther students, welcome to another video tutorial. Today's video is going to be for both pre-algebra and algebra, and we are going to begin to practice a bit with different kinds of angle relationships. We're going to start off with the two most basic angle relationships, and the assignments that follow this video will also be at their most basic level, but we will gradually increase the difficulty as we move through, as we move from lesson to lesson. So today we're going to talk about complementary and supplementary angles. And the goal is, because I know this is technically a 7th grade standard, but I know when I taught 7th grade last year, I did not reach this point in the curriculum, and we are going to build upon it to the 10th grade level. So we're going to start at the 7th grade level, work to the 8th grade level, and then we will end on the high school geometry level, okay, in future videos. This one is just meant to get us started. Okay, so this will carry us through the 7th grade and 8th grade level, and then for the algebra kids, we will move on to the 10th grade level in an upcoming video. Okay, so I don't want you to just simply be able to, tell me what a complementary group of angles are or what a group of supplementary angles are. I want you to be able to describe how we can solve for a missing angle in these different kinds of groups. And I want you to be able to explain how you know beyond a shadow of a doubt that your answer is correct. Because these angle relationships it's pretty much just logic. Okay, and you'll see that as we get through the next couple slides. Okay, so I am more focused on the why today than the how. Okay, so let's go ahead and move forward. Before we talk about complementary and supplementary angles, we need to review two very important and very common types of angles that you will see in geometry. Okay, and those are right angles and straight angles. Now, we should all pretty much be familiar with a right angle. Okay, a right angle is equal to exactly 90 degrees. And for those of you who have, studied different types of triangles, you will most likely know and have seen, a right triangle before. Okay, and a right triangle has this little box down here in the corner, and that box tells you that that angle is equal to exactly 90 degrees. Okay, and a slightly less common angle in earlier grade levels, but one that you do study nonetheless, is what we call the straight angle. Okay, and a straight angle is equal to exactly 180 degrees. Okay, so this angle right here is equal to exactly 180 degrees. Okay, and the right angle right here is equal to exactly 90 degrees. Okay, and to put the straight angle in a bit of maybe a more familiar context, if you were to imagine, okay, we continue this angle, okay, on the other side of this line here, okay, that would give us a full circle. Okay, and as many of you have told me at various points throughout the year, when we've, kind of reviewed circles, you guys know, from prior math classes and from your 360 no scopes that you do in, Warzone and Apex and all of that stuff, you know that the distance all the way around a circle is 360 degrees. Okay, so a straight angle is basically just half a circle. Okay, so you take the 360, cut it in half, okay, and you end up with 180 degrees, and that's where the exact measurement of a straight angle comes from. Now, with complementary and supplementary angles, what we are going to do is we are going to take these right angles and straight angles and we're going to divide them into separate pieces. Okay, so if I bring that and make that visible, okay, I have taken this one 90-degree angle right here and I've divided it into two separate pieces. Okay, and over here, with the straight angle, okay, I just kind of make that line appear, and I've taken this 180-degree angle, and once again, I've divided it into two pieces, or I've cut it into two different pieces. Now, I just kind of chose the direction of the arrow, at random. I could have drawn it so that it looked like that. It doesn't really matter. The arrow can go in any direction, as long as it cuts through the angle, and there can be more than one arrow going through this, so maybe we don't chop it up into just two pieces, maybe we chop it up into three pieces. So let's transform, if it would cooperate with me, mirror in the y-axis, and there we go. Now we have divided this straight angle into three separate pieces. Okay, and the complementary angle is currently divided into two pieces. But basically, what we are going to do is we're going to take the fact that we know, without these arrows, okay, we know the exact measure of these angles, right? This one right here is a right angle, so that's equal to 90 degrees. So we know that when we add these two angles created by this arrow right here, we know when we add this angle right here in red to this angle here in green, we know that the total is going to be 90 degrees. Okay, that's what it has to equal to. And if I could find my invisible line again, same thing happens right here. Okay, if we take this, let's see, let's use purple. If we take the purple part of this angle right here, okay, which is this section, and we add it to this orange section right here, doing my best to color with the mouse once again, we know that when we add those two angles together, we know that they must equal exactly 180 degrees. Okay, and that's basically the definition of these two relationships. Okay, so complementary angles add up to exactly 90 degrees. Okay, it could be two angles, it could be three angles. It's basically a group of angles that have a sum of exactly 90 degrees. Okay, not 91 degrees, not 89 degrees, but exactly 90 degrees. Okay, and very similarly, over here, supplementary angles, okay, are two or more angles that equal exactly, not 90 degrees, 180 degrees. Why does it keep disappearing? Hold on. There we go. Supplementary angles add up to exactly 180 degrees. Okay, and I cannot emphasize how important the word exactly is with this concept. Okay? These are exact measurements, and if they equal anything else, okay, they can't be complementary or supplementary. Okay? So, here's one of my favorite things to discuss involving complementary and supplementary angles. Because you have to, I guess when you reach 10th grade geometry, or just geometry in general, you are going to have to, on your own, know the difference between a complementary and a supplementary angle. Okay, in years past, when we weren't quarantined, I would see some students, on the test, they would know, okay, We're looking at complementary angles here. I can't remember. Is that the one that equals 90? Is that the one that equals 180? Okay, and then, as much as I wanted to help them, okay, knowing the definition and being able to distinguish between the two is one of the skills that we are going to work on. Okay, so here's how I remember the difference between the two. Okay, so I want you to look at these arms down here. Okay, and some of you may already see where I'm going with this. So we have on the left here a regularly toned arm, okay, from somebody who, lifts weights. And over on the right here, we have this just ridiculous behemoth of a bicep that was clearly not sculpted, or it's not something this guy acquired just by lifting weights. Okay, he used something to help make it bigger than usual. So what I do is, okay, I think of complementary, okay, and I know that the spelling is different. Okay, but complement. Okay, so complement, I think, if I were to see someone with an arm like this, I'd be like, hey, you've got some big arms right there, And then you look at the guy on the right here, and he, rather than giving him a compliment, okay, I know that he used, okay, and this is for those of you who are big-time sports fans, sometimes athletes get in trouble for using what we call supplements, okay, and those can be things like steroids or other performance-enhancing drugs. Okay, so I think of the supplementary angles, those are the steroid angles. Okay, they're the ones that add up to the big, 180 degrees, whereas complementary angles add up to, the well-toned but not overly terrifying 90-degree angles. Okay, so complement, okay, is, a well-toned angle. Supplement is a big, terrifying steroid angle. Okay, that's how I remember it. Hopefully, that will help you as well. I will leave these graphics up for the next few examples. And here's an example of the 7th grade level, or a look at 7th grade level complementary and supplementary angle problems. Okay, so we have one of our two angles here has been given to us. Okay, we know this angle right here is 44 degrees, and we're not quite sure, although some of you may be ahead of me and you may have already solved for x on your own. We don't know the exact measurement of angle x yet. But we do, in fact, have enough information to use some very basic algebra and equation and variable solving skills in order to figure out what angle x is. Okay, so what do we know about these two angles? Well, we know that when we add, okay, when we take angle x, right, and we add the 44 degrees to it, we know that the total is going to be, well, this is a right angle right here that both of these are going to add up to. So we know that the total has to be exactly 90 degrees. And what we have here, ladies and gentlemen, is another one-step equation. Okay, and we've solved these a million times. Okay, and we've solved 2-step equations, 3-step equations, all the way up to 5- and 6-step equations. And these work exactly the same as the other ones. Okay, so our goal is to isolate x. So we need to cancel out everything else on the same side of the equal sign as x. So because it's a one-step equation, the only thing we have to cancel out is that plus 44. And we are going to force that 44 to equal 0 by subtracting 44 from both sides. Okay? Positive 44 minus 44, that cancels out because it equals 0. And that gives us x is equal to, oops, that was a terrible, terrible equal sign, is equal to 90 minus 44. Okay, and that is going to give us a total of, let me write it in green, actually. Actually, no, I'm going to write it in red. It's going to be equal to exactly 46 degrees. Okay, so this angle right here in red is equal to 46 degrees, because when we add them together, we get the 90-degree angle. And we also know that they're going to equal 90 degrees because they are complementary. Okay, so that's an example of a basic complementary angles problem. Let's move over to the right here and take a look at something very similar. Okay, the supplementary angles problem. I don't know why that's right there. There we go. Okay, so when we add these two angles right here, okay, I'll color over this one in yellow. Okay, we know this angle right here is equal to 100 degrees. And then this angle over here in red, okay, we're not quite sure yet. And if you already are sure of what it is, we're going to pretend that we're not. We're not sure what angle x is yet. Okay, but once again, we do have enough information to figure it out. Okay, because we know when we add angle x to the 100 degrees that we have down here, we know that because they are supplementary, that they are going to equal, it's going to equal 180 degrees. Okay, and just like with the complementary angles question, we have ourselves a one-step equation. Let's isolate x by canceling out the positive 100. Because the 100 is positive or being added, once again, we are going to subtract 100 from both sides. And that's going to force these to cancel out. Okay, so those have canceled out. And then we get x is equal to 180 minus 100, which is 80 degrees. That's an 80, not an 86. There we go. And there we are. We have figured out the measure of angle x. Okay? So, in my opinion, the most difficult part of this work is just committing to memory, okay, complementary angles equal 90, supplementary angles equal 180. Okay, other than that, you guys all have the skill set that you need to figure out, a missing angle. Okay. Let's go ahead and move to another set of examples. Apparently this one's locked. There we go. So I'm going to, for this supplementary angles problem right here, we'll go back to the complementary in just a sec. I'm going to just show you that I can make up these problems as I go. There really is no magic to these kinds of problems. We'll make that just a little bit bigger. There we go. And this time, what we're going to do is, instead of... Actually, no, I'll save that for the next problem. Let's do something very similar. Okay, so we have a complementary set of angles right here. Okay, so I'm going to go ahead and tell you guys, okay, so this angle right here, that's going to be equal to, we'll say, 36 degrees. And this angle right here, we're going to call that angle Z. Now, what I'd like for you to do is, I'd like for you to pause the video, and I want you to see if you can figure out the measure of angle Z. Okay, I'm going to assume that you've tried it, and let's go ahead and solve it. So I know that these two angles, when I add them together, so when I add Z together with 36, I can tell by looking at the angle, but also because it's labeled for me as complementary, I know that the total is going to be exactly 90 degrees. Okay, and in order to solve for angle Z, I'm going to cancel out the 36 by subtracting it. I wonder if the sensitivity on my mouse is too high. Like, this is crazy. I'm going to subtract 36 from both sides, and that's going to give me Z is equal to, and then let's write it in red again. Z is equal to 54 degrees. Okay, so this angle right here is equal to exactly 54 degrees. Okay, let's come over here. Same thing. I'm going to write a problem for you, and I would like for you to attempt to solve it on your own. If you get stuck, that's okay. We're going to go over it again together. If you get an answer, we'll see if it lines up with mine. Okay, so we'll say that this angle right here is 71 degrees, and I'm going to call this angle over here, we'll call this angle Y. Okay, so go ahead and pause the video and see if you can figure out the measure of angle Y. Excellent. Okay, so I know when I add 71, when I add that to whatever angle Y ends up being, hold on a second, I'm going to turn down the sensitivity. There we go. When I add that to angle Y, whatever it is, I know that the answer is going to be, 180 degrees. We need to get Y all by itself, so we need to cancel out this positive 71 right here. So I'm going to do that by subtracting 71 from both sides. That makes this equal 0. So it cancels out. And then we end up with Y is equal to 180 minus 71, which gives us 109. Okay, so we know that 109 degrees. So we know that angle Y down here is equal to 109 degrees. Okay. Let's go ahead and turn the difficulty up just a little bit. Let's start with these angles over here. Okay, so this time I've divided this straight angle into 3 different angles. Okay, but that still doesn't change the fact that we know that they're going to be equal to 180 degrees. Okay, so we'll start with, we'll do that, and we'll do that. Okay, so what if we say this angle right here is equal to X? We say that this angle right here is also equal to X. And then we say that this angle right here is equal to, we'll say, let's say 58 degrees. Now I know some of you might look at that and say, oh my goodness, we've got 3 angles, we've got 2 variables. This problem just got a whole lot harder, didn't it? Well, not necessarily. Okay, we're still going to set up the problem exactly the way we did the last two sets of examples. Okay, we still know that when we add all 3 of these angles, okay, so we know when we add this red angle X, when we add that to the orange angle X, and we add that to our green angle here of 58, we know that all 3 of these angles added together is still going to equal exactly 180 degrees. Now, the only thing that has changed here is that instead of this being a one-step equation, we're now dealing with a 2-step equation. Okay, so in order to set up the 2-step equation, remember, we need to look at both sides of our equal sign, and we need to check for any like terms that can be combined together. Okay, so I look over here, and I see that we have 2 like terms right here that we can combine together. So that's going to give us, let's see, I'll tell you what. I'm going to move this over here, and we'll do it over here in this area. So x plus x is going to give us 2x. Okay, there was nothing to combine the plus 58 with, so it just kind of stays exactly the way it is. And this is still going to equal exactly 180 degrees. And now the 2-step equation is set up. And if it's been a while, I would suggest taking a look at your multi-step equation notes in your interactive notebooks. And let's go ahead and solve this together. Okay, so we know that we cancel out addition and subtraction first. Okay, so we have addition right here, so we want to make that equal 0. So we are going to do the opposite of addition, which is subtraction. So let's subtract 58 from both sides. That's going to force this to cancel out, okay, which is exactly what we want. Okay, so that has canceled out. And the only thing on the left side of the equal sign that remains is the 2x. That's going to equal 180 minus 58, which is 122. Let me just double check that. 180 minus 58. Yes, 122. Okay, and now we have got this thing down to a 1-step equation. So the last thing we have to cancel out is the 2. The 2 and the x are right next to each other with no sign in between them, which means they are being multiplied. So to cancel out multiplication, we do the opposite of multiplication, which is division. So we're going to divide both sides by 2. That is going to force the 2's to cancel out. So we'll get x is equal to 122 divided by 2, which is 61. Okay, so x is equal to 61. So that means that this angle right here is equal to 61. And this angle here, which is also given to us by the problem, it says that it has a measure of x. Well, we just figured out that x is equal to 61. Okay, and if we bring up the calculator again, if we add all 3 of these angles together, if the total is 180 degrees, chances are we have done it all correctly. So 58 plus the first 61 plus the other 61. There we go, 180 degrees, and we have done it perfectly. Okay, and this on the right here, or these examples on this page in general, these are more of an 8th grade level version of complementary and supplementary angles. Okay, because it combines, what you know about right angles, straight angles, complementary angles, supplementary angles, one-step equations, two-step equations, inverse operations, combining like terms. It's a lot of different ideas coming together into one single problem. Okay, and let's go ahead and move over here to this problem. Okay, so we have this angle here in orange. We have this angle right here in green. And we have this angle right here in red. Okay, so I'm going to give you enough information that you need in order to solve the problem. And then if you feel like you've got the hang of this, go ahead and pause the video and try and solve it on your own. But you don't have enough information to do that yet, so let's change that. So we'll say that this orange angle right here is equal to, how about, we'll say 20 degrees. We'll say the red angle down here is equal to 15 degrees. And then we'll say that, we'll say that the green angle is equal to, actually, you know what? Change my mind. We're going to change the red angle to 10 degrees. And we'll say the green angle is equal to 2x. Okay, so now that I have filled in the angles, now you have enough information to figure out the measure of the green angle. Okay, and at this point, okay, we know the red angle is 10, we know the orange angle is 20, and we know that the green angle is going to be equal to 2 times whatever x ends up being. So we need to figure out what x is before we can figure out the measure of the green angle. Okay, so you know enough information. If you feel like you want to try it, go ahead and pause it and go ahead. If you feel like you're still a little bit lost, that's all right. We're going to go over it together right now. Okay, so let's go ahead and write it up here. So we know when we add the orange angle right here. Okay, when we add, again, I don't much care for that. There we go, the 20. When we add that to 2x, and we add our third angle here of 10 degrees, we know that all three of these angles, when we add them together, these are all complementary. Okay, they're going to equal the measure of a right angle, and a right angle is equal to 90 degrees. I'm going to move that over there, and we'll do the work over here in this blue space. Okay, so the first thing we want to do, just like with our supplementary angles, is we want to combine any like terms that are on the same side of the equal sign. So I look over here. We have a number here without a variable, and another number right here without a variable. So those are like terms, meaning we can combine those together. So 20 and 10, they're both positive, so that's going to give us 30. There is, unfortunately, not another term that has an x, so there's nothing to combine with the positive 2x, so it just gets written exactly the way it is, and we know this is still going to equal 90 degrees. Okay, so we have now reached the same step as right here. Okay, we have set up our two-step equation, and now our goal is to begin canceling out everything that's on the same side of the equal sign as x. Okay, and we're going to cancel addition and subtraction first. Okay, so let's cancel out this 30 right here. Okay, we want to make this equal 0. It's a positive 30, so I know if I subtract 30 from both sides, that will force it to cancel out. Okay, and then 90 minus 30 would give us 60. And that's going to be equal to the only thing remaining on the left side, which is 2x. Okay, and the last thing to cancel out is the 2. The 2 and the x are on the same side of the equal sign. And there's no sign in between them, which means they are being multiplied. So we are going to divide in order to cancel out the 2. So that cancels. That's going to give us x is equal to 60 divided by 2, which is 30. Okay, x is equal to 30. Okay, and now you want to be careful right here because 30 is not our final answer. Remember, we are trying to figure out the measure of the green angle. Okay, so the measure of this angle right here. Okay, solving x was a part of solving for the green angle. Okay, and at this point, many students on Khan and on their tests and on their projects and assignments, they would put, okay, the answer is 30. Well, not necessarily. That's what x is equal to, but the problem didn't ask us to solve for x. Okay, the problem wants us to solve for the measure of the green angle, and the green angle is equal to 2 times whatever x is. Okay, so we just figured out that x is equal to 30. So instead of it being 2 times x, let's write 2 times 30. And that means the measure of the green angle is equal to 60 degrees. Okay, and that would be our final answer. So we know the green angle is 60, the orange angle is 20, and the red angle is 10. And let's double check our answer. If we've done it correctly, when we add all 3 of these together, because these angles are complementary, they will equal exactly 90 degrees. 20 plus 60 plus 10 equals 90. And there we go. Okay, so that's a couple of examples at various levels. I'm not going to give you any work yet, today that has to do with, the 3 angles or mixing in variables. So like the 8th grade level of the work, we're going to start off with a few Khan assignments that deal with these problems at the 7th grade level. Okay, like these ones here. Okay, or these ones here. I want you to let me know, okay, if you get stuck. And remember, I am tutoring this Thursday, which I believe is the 9th. Let me double check on my phone just to make sure that I don't give people the incorrect date. Yes, this Thursday the 9th at 6 p.m. for algebra and 7 p.m. for pre-algebra. Okay, if you have questions about today's assignments and you are not able to make the tutoring session, which will be live streamed on my YouTube channel, so the same channel, that's just below this video, if you're not able to make the tutoring session or the live stream in general, please leave your questions on Google Classroom in the comment section below this post. Or you can leave your questions below this video here. I'll answer them during the live stream, and then I will re-upload the live stream to YouTube. So even if you're not able to make it, you can get your questions answered. Okay? All right, you guys. I know this was a bit of a long video, but, we covered quite a bit, in a relatively short span of time. Remember, the content only gets more difficult from here. Okay, we've done the 7th grade version and the 8th grade version. For those of you in algebra, the 10th grade version is coming. And for those of you who are in pre-algebra, there are some assignments for the 8th grade version coming up soon. All right, you guys, take care. And again, let me know if you have any questions. I'll talk to you later.